So we eliminated A, B, and E by the max at 2 and the min at 3, based on the sign change of the derivative. And then we eliminated D because we needed to have points of inflection at 1, 2.5, and 3.5. Did I answer your question there, Yaya, about that? Did that make sense? Why I would be hesitant to do that?
Yep, thanks.
No problem. Yeah, that was you talking, right?
Yep, that was me.
All right, great. I can recognize one student's voice. That's exciting. After listening to you sit silently in core class for some number of years. All right, let's look. I didn't want to put a new page in. I wanted to put in problem number 83. Let's look at number 83. So we got a table with values of f, and f is increasing on the interval 0 to 3. We want to know what could be the value of the integral from 0 to 3 of f of x. Let's see here. There's lots of different ways we could go about this, really. We could do, let's see. I think the best way is, since we know that f is increasing, we know that a left Riemann sum will underestimate the value, right? And a right Riemann sum will overestimate the value. So if we were to find the value of a left Riemann sum and a value of a right Riemann sum, it would have to be between those two values. So if we did, it'd be a half of 0 plus, they're all going to be a half. So let's just call it half of 0 plus 4 plus 10 plus 18 plus 28 plus 40 is your left Riemann, and a half of 54 plus 40 plus 28 plus 18 plus 10 plus 4 ought to be your right Riemann sum, and it ought to be between those two values for the actual integral. So I don't know, what does that come out to be? That's 50, 60, 70, 80. Looks like this one is 50. And this one, what is that going to come out to be? Somebody do that arithmetic for me already. 94, 104, 114, 134, 138, 148 ought to be 154, and half of 154 ought to be 77. So it looks like it ought to be 62. Because it has to be between the under and the overestimate. Does that make sense to everybody? That's a good problem. I like that problem.
It does make sense, yeah.
Oh, good. Cool.
Wait, I have a question. Could you just midpoint Riemann sum it? Because like midpoint's technically in the middle of both of them.
You could, but I mean, the midpoint should have come out. Did the midpoint come out to be 62? No, it shouldn't have come out to be 62.
It was 62. So
it was 62. Wow, that's a little surprising. Yeah, I mean, a midpoint should be between. If it came out to be 62, then sure. But the midpoint one, well, I guess the midpoint one should come out to be the average. No, it should. Never mind. That's what a trapezoidal sum does. Comes out to be the average. So you could have done a trapezoidal sum. It's just, I think, lucky break that the midpoint one could have come out to be it. But the trapezoidal should be yeah, I mean, I guess if the intervals are equal, yeah, then the midpoint should come out to be the average of the two. So that makes sense. Yeah, that'd be fine. Yep, that would work. But it's possible, you know, they could, I mean, I could have put an answer in here that was 76. You know, if 76 was an answer choice, that would also work. So like your midpoint's not going to come out to be 76. So that's not, I mean, you're not guaranteed. If the number that you get from your midpoint is exactly one of your values, then sure. But that's just a, I mean, they probably did that intentionally, but it's just, you know, happenstance that that occurred. That you could have, any value between 50 and 77 would have been a legitimate answer choice. So, does that make sense?
Thanks.
Yeah, no problem. All right. Okay. Let's see. I think that is everything from 2013 that anybody asked for. So now we will move to 2014. I'm going to just try and do these sort of in the order that people wanted them here. So 24. 24 from the 2014 test here. Let me go find that problem. Put it in here. 24, 2014. This is the one, right? Did I just take the wrong? I might have taken that from the wrong test. No, that's the right test. Okay, good. So 24, we're looking for horizontal asymptote. This is a rational function, right? So if it's a rational function and you're looking for horizontal asymptote, look at the degree of the numerator and the degree of the denominator. Degree of the numerator is 2, degree of the denominator is also 2, right? Because it's 3x times the negative 4x will give you a negative 12x squared over a 2x times a 2x will be a 4x squared. And if the degree of the numerator and the denominator are the same, divide the leading coefficients to find the horizontal asymptote, and it's just y equals negative 3. Any questions on that one? Okay, Kylie, you said you had said 21, but then you said not 21. Is that correct? Just want to make sure if you want 21, I can do it. Yeah, okay, we did 21 yesterday. Okay, all right, I just want to make sure. All right, 26. We are looking for the derivative of an integral from a constant to a function. So this is the first part of the fundamental theorem of calculus. It says, taking the derivative of the integral from a constant to a function of some other equation, replace the t in that other equation with your function in the upper limit, and then multiply by the derivative of that function. So this becomes 1 over 1 plus x times 1 over 2 root x, which is choice A. Any questions there on 26? All right, now Kylie, I'm still confused. Do you want 80 or no? Or did we do instead of, I don't know, what you wrote is all very confusing. I see you want 83 and 86, but then I wasn't sure what you were saying about 80 and 89. Okay, all right, 83 it is. All right, so we're looking at f and g, which are continuous functions, and we're given some integrals, 0 to 6 of f, 3 to 6 of f, 3 to 0 of g, and so on and so on. We want to find the integral from 0 to 3 of 1/2 f of x minus 3g of x. So first off, this should just be 1/2 of the integral from 0 to 3 of f. I'll write these separately, minus 3 times the integral from 0 to 3 of g of x. I think it's easier if you just look at them separately. What's the integral from 0 to 3 of f? Well, we don't have that, but we know the integral from 0 to 6, and we know the integral from 3 to 6. So the integral from 0 to 3 ought to be the integral from 0 to 6 minus the integral from 3 to 6. So 9 minus 5. And then the integral from 0 to 3 of g of x, well, this is 3 to 0. So you got to flip the sign to make it a positive 7. So you end up with 4 divided by 2 is 2, minus 21 is negative 19. Any questions there on that one? Does that make sense to everybody? I don't know why I'm writing an 86 there. We're just going to go find 86. And I'm going to put it in here. Oh. All right, I swear I've done 86 like 4 times. I don't know if it's been in this class or the other class. I've done it lots of times. It's a good one, though. We'll do it again. Whether we did it in this class or not, I have no clue. So we're looking for the line that is tangent to y equals e to the x at some point k, e to the k. And then we want to figure out when its y-intercept is a half. So the first thing that we have to do is just write the equation of the tangent lines. In order to do that, we need a slope and a point. There's our point. Our slope ought to come from the derivative, which is e to the x. And we got to evaluate that at x equals k. So our slope ought to be e to the k. So we will write out the equation as y minus e to the k, y minus y1, equals slope e to the k, times x minus k. So this is L. And L is this. We want to know when is the y-intercept of L a half. Well, the y-intercept is 0, 1/2. So when x is 0, y is 1/2. And that gives us 1/2 minus e to the k equals negative k e to the k. And this is not something you're going to just be able to solve without a graphing calculator. You need to see when those equal each other. So you'll do that on your graphing calculator, but since I've got Desmos, 1/2 minus e to the x and negative x e to the x. Looks like that. Where do they intersect? Well, 2 times, 1 here and 1 here, but it asks for the positive value. So that should be 0.768. Just get that from the graphing calculator. Any questions there on that one? Everybody okay with that one? Sorry, did you ask about explaining? I just saw it. Can I explain the last step again? Was that the last step of this one? Or did I miss that earlier? Okay, yeah, so after we plug in the y-intercept, after we plug in 0, 1/2, we end up with this. We end up with this system of we end up with this equation, 1/2 minus e to the k equals negative k e to the k. And so in order to figure out for what value of k this is true, because our only variable in here is k, Right? E is just a constant and a half is a constant, and negatives are negatives. So all we do is we graph both of these equations. If you're doing your graphing calculator, you'll just graph 1/2 minus e to the x, and you'll graph negative x e to the x, and you'll just look and see where they intersect. So and that's what I did here. I graphed 1/2 minus e to the x and negative x e to the x, and their intersection point is 0.76. That is the value that makes that statement true. Does that make sense now? All right, and somebody else was now just asking about number 80 from this one again. So whether we did it yesterday or not, we can take a look at it just to make sure we're good with it. And then we got one free response question to take a look at also. So number 80 here says that our function is twice differentiable and that the second derivative is positive, which tells us that it's concave up. And what we talked about the last time was that if a function is concave up, that means that the slopes are increasing. Right? Second derivative is positive means the first derivative is increasing. And f prime increases if its derivative is positive. So we want to know what could f prime of 3 be. And so we will look for what is the average rate of change between 1 and 3. So 3.6 minus 2.4 over 3 minus 1, which is 0.6. And then we'll look for the average rate of change here, 5.4 minus 3.6 over 5 minus 3, which ought to be 0.9. And then we will say, since the average rate of change between 1 and 3 was 0.6, somewhere on that interval, the instantaneous rate of change must have been 0.6. And somewhere on the interval between 3 and 5, the instantaneous rate of change must have been 0.9. Therefore, at 3, if these slopes are always increasing, it has to be something between 0.6 and 0.9, which is 0.7. That makes sense to everybody there for number 80?
Yes.
All right. And then somebody wanted 5B. I'll go down and find 5B. And then we will work through that one. So there's 5, the initial stuff for it. And specifically part B. So particle x moves along the positive x-axis. This is its position. We want to know when is it furthest to the left. It can be furthest to the left anytime its velocity is done being negative. So we will just figure out its velocity equation. V of t ought to be 15t squared minus 18t, which if we factor out a 3t, from that gives us 5t minus 6 and tells us t equals 0 and t equals 6/5 are critical values there. We're not concerned about anything less than 0, so we'll just put 0 and 6/5 on there. And if we plug in something like 1 to this, we end up with a positive times a negative, which tells us that the velocity is negative, which tells us that it's moving to the left this entire time. And then greater than 6/5, like 1,000, this is positive. So it's moving left, then it's moving right. So it must be farthest to the left when it's done moving to the left. at t equals 6/5. And your justification would be the particle is moving left on the entire interval from 0 to 6/5, but then begins moving right at t equals 6/5. Does that make sense to everybody? Everybody good with that one? All right. I'm looking through. I think oh no, I didn't hit everything. That was 2014. We still have a couple from 2015. A couple from 2015 that we'll do real quick. Starting with number 87. All right, so for 87 here, we've got a piecewise linear function. And we know that h is the integral of this function from -1 to x. Oh, geez, I don't know what I just did there. Okay, there we go. Let's try this again. We want to know, when is h increasing? Well, h is increasing if h prime is greater than 0. So we want to know, when is h prime positive? Well, we need to find h prime. H prime ought to equal f of x, right? The derivative from a constant x of a function. So h prime is f of x. So when is f of x greater than 0? Well, f of x is greater than 0 from 3 to 9. And we put the brackets on because it's talking about an increasing or decreasing. Everybody good there with 87?
Yes.
Great. And then 92. All right, so for 92, we're looking for which of all these different things has the largest value. So, let's take a look at them all. The average value of h from -3 to 2, well, that ought to be 1 over 2 minus -3 times the integral from -3 to 2. No, it's not f of x, it's h of x. Huh? That's part A. Okay. So that's 1/5 of this integral. Well, here we go. C is that integral. So 1/5 of that integral, we would think would be less, maybe, but it depends on if that integral is positive or negative. So what's the integral from -3 to 2? Well, the integral from -3 to 2 of h, that's a pretty big negative section. And this time, yeah, you'll note that there is a scale here. So it's pretty clear that this piece is greater than this tiny little positive piece. And then we have more negative, and then we have another small positive piece. So it looks like the integral from -3 to 2 is negative. and 1/5 of that then. So if I take 1/5 of something that's negative, I actually get something that's larger. So I can immediately eliminate choice C. If I were to look at the integral from -3 to 0, from -3 to 0, I've got, I got this big negative with a little positive, but this is subtracting a little and this is adding a little more. So this value is a smaller negative value from -3 to 0 than what I'm adding back into 0 to 2. So I can eliminate this -3 to 0 one, which is also negative, just something to note. H prime of 0 is the slope at 0. Well, that's also negative, but it's hard to determine if that is in comparison to this, which one of these things is larger. But if we look at the average rate of change of H on -3 to 2, well, the average rate of change of H is the slope between the endpoints. Well, that is positive. Everything else we looked at was negative. That's the only one that was positive. And so positive one must clearly be greater than all of the other negative ones. Does that make sense? Everyone good there or no?
Good.
Wonderful. All right. Anybody have any other questions?